Hello, welcome to Graphs of Trigonometric Functions. In this video, we are going to talk specifically about the functions of sine and cosine. We will go over the important definitions and concepts that are needed for writing these equations from a graph and do some practice. But first, why should we care about periodic functions? Brown shows us that a relationship exists between right triangles, unit circle, and sinusoid. One builds upon one another, and if the amazing connection of math doesn't interest you, periodic functions also have real-world application. For instance, the movement of a Ferris wheel or different waves like sound, light, and the ocean can all be represented with sinusoidal functions. So too can blood pressure and many other things. So understanding periodic functions can help you understand the world. Let's begin by reminding ourselves what the sine and cosine graph look like. We know that every point on the unit circle is related to a point on the periodic graph. So plotting, say, the sine values and graphing gives this graph here. And doing a similar process for cosine will produce this graph. So the many points on a unit circle can all be plotted graphically, which gives us our periodic functions. Sine and cosine also share many characteristics. They are both periodic with a period of 2 pi, have a domain of negative infinity to infinity and a range of negative 1 to 1. However, they differ in symmetry. Sine of x is symmetric about the origin, which is this graph here, and cosine of x is symmetric about the y-axis, this graph here. Next in our presentation are the key terms needed to write trigonometric equations from a graph. Please pause the video here and make sure you're familiar with these terms. Now with the key terms defined, let's move on to the equation. Sine and cosine can be represented by the general equation y equals a sine of bx minus c plus d, or y equals a cosine of bx minus c plus d. In both cases, a is the amplitude. It has absolute value signs as distance is positive. The amplitude can be solved by finding the minimum point on the graph and subtracting it from the maximum, and then dividing the quantity by 2. B is found by dividing 2 pi by the period. D is the midline and can be solved by adding the maximum and minimum value and dividing it by 2. And the phase shift is the quotient C divided by B. To write an equation from a graph, the steps are to first identify the function and the general form of the equation. From there, you'll need to determine the amplitude, B, and the midline, and then finally substitute the found values into the equation. Also note that for today's video, we won't be worrying about phase shifts. Now that we have the concepts and equations down, let's begin. Here is our first example. We know the graph is cosine, so the general form without the phase shift is y equals a cosine of bx plus d. Our maximum point is 2, and the minimum is 0. Using those values, we have the amplitude formula as max minus min divided by 2, so 2 minus 0 divided by 2 equals 2 divided by 2. Simplify and the amplitude is 1. For the period, the cycle pattern lasts 2 pi, which is shown by this highlighted part. So b equals 2 pi divided by the period, which equals 2 pi divided by 2 pi, and this is 1. The midline formula is similar to the amplitude, but this time we will add the maximum and minimum value. This gives 2 plus 0 divided by 2 equals 2 divided by 2, so the midline is 1. Now that we've found the key characteristics of a periodic function, we can substitute our found values into the general formula. Doing so gives the equation for this function as y equals cosine of x plus 1, which is the answer that we want. Here is another example. Notice that we have the sine function, so the general equation is y equals a sine of bx plus d. The max is 2, the min is negative 4, so the amplitude is 2 minus the quantity negative 4 divided by 2, which is 6 divided by 2. Being careful with the negative sign and simplifying gives the amplitude as 3. Our period is 4 pi, so b equals 2 pi divided by 4 pi, which is equivalent to 1/2. The final piece is the midline. We have 2 plus the quantity negative 4 divided by 2, which is negative 2 divided by 2, and so our midline is negative 1. Now substituting into the general form, and the function's equation is y equals 3 sine of 1/2 x minus 1. For example 3, let's have you try it. So pause the video and see if you can work it out. Did you get y equals 5 sine of x plus 3 as your equation? If you did, great work, and if you didn't, feel free to take a look at my work to help guide you. Here is one last example for you to try. Again, pause the video and see if you can work it out on your own. The answer here is y equals 2 cos of 3x minus 1. In summary, periodic functions aren't just necessary for math classes. They can be found all around us. So if you want to write periodic functions from graphs, remember to determine the general trigonometric form. Find the amplitude, b, and the midline, and then substitute back into the general equation to find the equation of a periodic graph. I hope that this video helped you learn about graphs of trigonometric functions, and thanks for joining me today.